Hi, everyone, and welcome back. It's Kira Garfola with Greenville Tech's Math 155. Today, we're going to talk about section 1-2, which involves rounding and approximate numbers. Most of this should be a real quick review. I'll kind of move quickly. Of course, if you need more help, there are other supplemental lessons within our Blackboard shell. You can always reach out to me, and I'm happy to help as well. Okay. So before we get into rounding, remember that you need to understand place values. Our decimal point is that tipping point right here. And if we go to the left to numbers bigger than the decimal, we have our ones place, our tens place, hundreds, and so on. Now, it goes a little differently past the decimal on the right, okay? We don't have a ones place. We just go to the tenths, okay? So we skip straight to the tenths, and then it follows suit, hundredths, thousandths, 10,000ths, and so on. It's that THS at the bottom that you're really looking for, okay? It's a good idea to be familiar with these at least up to the 10,000s on either side, because you'll see those fairly commonly in our course. So how do we round? Generally, we're going to look one digit to the right of wherever we're wanting to round. For our class, now if you've taken science classes and you've done significant figures, this may be different. But generally, mathematically, if the number is less than 5, then you're going to leave that digit alone. Okay, so the digit you're interested in rounding, look to the right. If that number to the right is less than 5, you're going to leave it alone. Now, if that number is 5 or more, you're going to up the digit of interest. Okay, this is one of those cases where it sounds a lot more complicated than it actually is. So for example, we went around 6.2872 to the 10th place. We know that the 10th place is this first decimal place. If we look to the right, we see 8 is that decimal. That's bigger than 5, so we're going to round up. To the 10th place, we would have 6.3. Now, don't get fancy with any of this, okay? Don't add extra zeros. Don't add anything fancy. If you had given 6.30 or 6.300 on either of these, those would be wrong. You are adding what we call significant figures, and it is making it look like it is rounded more precisely than it actually is. So if I say round to the 10ths, I want to see one decimal place, no fancy extra additions. Now, sometimes we have non-decimal situations, okay? Anytime you deal with a non-decimal situation, the first thing that you want to do is go ahead and look and see what a whole would mean, okay? What is a whole and what is a half? Half of a pound is going to be 8 ounces. Half of a foot is 6 inches, and so on, okay? If you are at least a half, you go up. If you are not at least a half, you go down. So for example, if you rounded 5 feet 7 inches to the nearest foot, 7 inches is more than a half and a foot, so you have more than 5.5 feet. So you'd round up to 6 feet. If you were rounding 10 pounds 6 ounces to the nearest pound, even though that 6 is bigger than 5, remember it's what makes half to be important. So 6 ounces is less than half of a pound, okay? So this would actually round down to 10 pounds. This is where science people would say, hey, the metric system's so much better because it's based on 10, and you don't ever end up with this garbage. Now, there are also special situations where maybe you don't want to round to a whole number or a certain decimal place. Maybe you don't want to round to the 10ths. Maybe you don't want to round to the ones, okay? Possibly you want to round to the nearest 5. In this case, think about counting by 5s. Where do you get closest? For example, 42 would go to 40, 45, or 50, so on. It's between 40 and 45. It is closer, the midpoint between these two is 42.5. So it is closer to 40. If you wanted to round to the nearest quarter, you're going by 0.25s. So if you wanted 87.46, remember it could go to any of these quarters, okay? It's somewhere between 0.25 and 0.50. 0.46 is definitely closer to 87.50. So that's what we would round to. A lot of my students have success maybe drawing a number line and seeing where it would plot. Whichever one of those digits you're closest to, that's what you want to go to. Okay, let's look at some examples here. If we went to round here, I'm going to take us out of this so I can type. The nearest hundredth is going to be the second decimal place. So we have 5.375 and something. The 7 is what we want to round, and we see a 5. So we're going to have 5.38. Okay. For this next one, we want to round to 2 decimal places, which is another way of saying to the hundredths. So we know that it's this digit we want to round. Okay. So we see the 8, we look over here, and that's a 4. So it's just going to stay the same. So we have 839.38, and we leave it at that. Lastly, to the nearest penny. Remember, pennies are hundredths, okay? So to the nearest penny here, we're going to still have the dollar sign. Oh, you guys, I'm on the struggle bus with this computer. This keyboard. Why won't it let me type? Okay, so we know that we're going to have 482 point. Now, 875 says 8 that we went around to. Okay, 98 cents. But 7 is larger than 5, so we're going to round up. So it's going to be 42.99. Easy peasy, right? Hopefully everybody's seen this before. Now let's think about a couple more examples, okay? We have this really big number, and we went around to the nearest 100. Now this is where we have to be very careful. We're talking about 100, not hundredths. So we want it to the nearest 100, which is right here, okay? This decimal place right here. So we're still going to have our 55,028. Now, what do we want to round it to here? Well, this one over here is a 5, so it's going to go up. So we're going to have 55, excuse me, 55,028,400. We have 0.3895 to the nearest whole number. Well, whole number is the ones place. This is 3, so it's less. So this is just going to simply be 0. 8 foot 7 inches. That's more than 8.5 feet, because 8.6 is 8.5. So this is going to round up to 9 feet. Okay. And let's do more practice. If we have 6 feet 5 inches and we went around to the nearest foot, even though that's a 5, that's less than 6.5, right? Because it's not 10 based. So this is actually just going to round to 6 feet. If we have 8 feet 5 2/3 inches, we still are under 8.5 feet. So this is still going to be just 8 feet. 35.67 to the nearest 5. Well, we know it could be 35.60 or 35.65 or 35.70. We know it's going to be between 35.65 and 35.70, and it is just a little bit closer, right, to 35.65. Again, number lines will be helpful here. If you want to think about counting by 5s, you'd have 35.60, 35.65, and then 35.70. The middle of these is 35.67.2 or 67.5, and we have 35.67 exactly. So it's going to be over on the left, and it's going to go to this 35.65. Okay, now we have something called precision in mathematics, okay? And it basically boils down to the number of decimal places. How precise can we be? If we're adding and subtracting 2 numbers, then the final answer can only be as precise as the least precise involvement, okay? So if you're adding and subtracting a bunch of numbers, go ahead and enter in your calculator exactly as you see it. But then round your answer to how many decimal places, the least decimal places there are. So here in this one, we have 2.76, we have 45.832, and so on, okay? We have lots here. We have 2 decimal places here, 3 here, what is that, 5 there, 3 there. The lowest number of decimal places we have is 2, okay? Have it there and we have it there. So even though this number is this, we need to round our final answer to only 2 decimal places, okay? So keep that in mind. That's always a test question and people always miss it. Just because this is what the calculator gives you, remember that you need to round to the best place. For example, we can just plug these directly in our calculator, but we don't want the calculator to lie with rounding. We have 0.3572 plus 0.012 minus 14.2. And that's going to give us negative 13.8308. But we see that 14.2 has only 1 decimal place. So we need to round this to only 1 decimal place to give us negative Man, this right click is really killing me here. Negative 13.8. Okay. Same thing if we type this into our calculator. We can get our answer. But we know this has 3 decimal places, this has 3, and this has 2. 2 is the fewest decimal places, so we need to round to 2 decimal places, and we will get 4390.66. Now there's another special case of rounding when we're using measured or approximate numbers, okay? Now remember, if you measure, let's talk about weight. You step on the scale every morning and let's say that it gives you to the 10th place, okay? So it says, hey, you weigh 142.6, okay? Well, that is not a precise weight. That's not an exact weight, right? Maybe you weigh 142.61008392, whatever. We are limited by our measurement skill, by our measurement technique, okay, and our tools. So if we have exact values, we don't have to worry about rounding, okay? We can do it for convenience, but we don't have to round. However, if we are dealing with approximate numbers, we will need to round. So again, some rounding is dictated by custom rules. We usually round money to pennies, right? The number of cents that we have. If you have ever filed your taxes on your own, you'll know that even though your forms tell you down to the cents, that they only want it rounded to the nearest dollar. So there's some places there. So that approximate numbers thing, just like before, make sure that you're using the fewest as you know. Okay, so last couple of examples here. Let's say that you have 19 jars containing 42 pieces of candy. And you want to know how many pieces of candy there are altogether. Is this exact or is it approximate? Well, you're not measuring the pieces of candy, you're counting them. Okay, you're not saying how wide they are, how heavy they are, or any of that. You know for a fact there are 42 pieces of candy in those 19 jars. We do not need to round here. Okay, we're simply going to type in 19 times 42, and that is going to give us 798. That is exact. So we do not need to round. Now, if we buy 14 items that cost $5.76 each, how much will you spend? We don't need to round here either. Okay. We don't need to round here because $5.76, that's an exact cost, and you know that you bought 14 of them. So you can just say 14 times 5.76, and you're going to get that you spent $80.64. Okay. This mouse hates me. I see the problem. It's going to be $80.64. Sorry for the delay there. I'll be on my computer hopefully by the next time recording. I'll have the right software. Okay, so just keep these in mind. Get some practice in your textbooks. It's a great idea to go ahead and practice. You can start looking at assignments, things like that. And again, remember, I'm always here if you need any additional help beyond that. Have a great day. Thanks for tuning in, and I'll see you next time.